So now let's start discussing about the data types. Okay. So in our previous examples, we have seen couple of data types. We understood that there are 8 data types in Java, right? But then, as I said, Scala does not have a data type. Scala has an equivalent class, which means if you have int in Java, then you have int in Scala. Whereas the difference between these two is, in case of Java, it is a data type, and in case of Scala, int capital I is basically a class. Okay. Now we'll start moving to the next topic, that is we will start understanding all these data type equivalent classes. Okay. Let's start with Boolean. So Boolean is basically a type which you can use when you want to store either true or false, right? For example, is married. Now there is only two answers to this, yes or no, and nothing else, right? Is female, yes or no. Is senior citizen, yes or no, right? So if you have any kind of variable which needs to store either true or false, then you would pick up a variable of Boolean type. Okay, so let's check this out. You can either say where flag is equal to true. Okay, when you say where flag is equal to true, this flag is basically a variable. Okay, var variable, and we have given a value true to it. Okay, now if you look into this code, what we did is we defined a flag that's of var type. Var means what? Variable. I can change it later if I want to, right? Okay. Now, as you all know, that you don't really have to write the type of it, right? And we call this type inference. Inference means it will be automatically detected and assigned. Here, I did not say that, hey, make this flag Boolean type. I did not say that, right? But Scala is smart enough. It says, looks like you are trying to hold true, and true comes under Boolean type. So let me automatically make this flag a Boolean type, right? That's what you can do. Or if you're jumping from a Java background and if you say, no, I want to write that data type as well. So if you want to do that, then you'll just give a double colon and you can specify the data type like this. Okay, so this is called as explicit typing, right? If something is done manually by the programmer, then we call it explicit. Okay, and if something happens automatically, then we call it implicit, of course. Okay, but then you might not be happy to use the term implicit because implicit has a different meaning in Scala. We'll talk about that later. Okay, so if something is done by the programmer manually, call it explicit. Now can we do something like this, where flag colon boolean is equal to 1 2? See, when you write boolean, you're supposed to say only true or false and nothing else. Okay, but can I do something like this? Can I say let where flag boolean is equal to 10? Can I do this? You cannot, right? Why? Because 10 means what? Integer, right? And you're trying to hold that value to a flag, right? You're trying to hold that value to a flag which is of boolean type, and boolean is not compatible with 10, right? And that's where you get an error like type mismatch error. So flag boolean 12 is not allowed because 12 is integer and you cannot have them in your boolean variable. Okay, now can I do something like this? Well, is true is equal to not true. Let's try this. Okay, small code, let me type it. Is true is equal to not true. So not true means what? False, and that would be assigned here. Okay, now let me try something like this. It did not work out here. Probably it is forcing me to end this because of this space. Okay, so be very careful whenever you are assigning. I would always say give a proper space and proper braces to make it super clear. Here what is happening is you just said well is true is equal to not, and then this is probably taken as an operator. Okay, and then this statement itself was declared as not complete, and hence it is giving you little trouble. Let me write it like this here directly. It says is equal to expected but found something, right? So which means because of this space problem, this too was treated as a method. Okay, whereas when you are very clear, then you are saying, oh, I would like to evaluate this first, and then whatever comes I want to assign it back to this. So be very careful when you are using this. Now, well is false is equal to not true. Not true means false, that means is false will be false. Okay. Now, well unequal is equal to 5 is not equal to 6. So if you look into this statement, what we have done is we're evaluating something. 5 is not equal to 6. That's true. 5 is not equal to 6. And since it is true, this true value would be assigned to your unequal. Unequal would get a value true. Okay. Similarly, well is less. 5 is less than 6. That's still true. 5 is less than 6. Right? True. And that would be assigned back to is less. Okay. So let's give it a try. Okay. So I'll say well unequal is equal to, and we'll say 5 is not equal to 6. 5 is not equal to 6. That's true. So unequal is true. Remember. And now I'll say well is less is equal to 5 is less than 6. Okay. That's also true. 5 is less than 6 true. Unequal is also true. Okay. Now let's say well unequal and less is equal to unequal and is less. So what we have done here is we're saying unequal and less. What is unequal? Unequal is true. What is less? Is less is true. And what we have used? We have used and. And I'll tell you the difference between these two. Okay. So true and true will give you true. Now similarly, what we have done is next statement well definitely false is equal to false and unequal. So false is basically a literal. Okay. It's a constant or a literal, you can say. And we have used here and here this is unequal. What is unequal? Unequal is true. So false and true would give you false. But you will understand this when we talk about what is the difference between and double and operator. Okay. Now this holds true in Java as well. In Java also you have operator like and or operator. Okay. These two operators are called as lazy operators or short circuit operator. Okay. What do you mean by that? Let's understand that in detail. Okay. Means they will not bother evaluating the second argument if first argument is sufficient to drive the result. What does that mean? See, take the example of this. If you fail in exams, will you get certificate? No, right? Which means whether you get certificate or not, that depends on whether you clear all the papers or not, right? Likewise, whenever you are working with Java and Scala, and probably I think it also works with C++. Okay, so when you're working with Java or Scala, you will come across this operator and operator, and this and operator are called as the short circuit operator, which means whenever you are using this operator, if the first condition is sufficient to decide the final result, then it will never evaluate the second parameter. Okay, so we are talking about and operator, right? And operator. Okay, now let's say you have written a code like this: condition 1 and then condition 2. So let's say you have two conditions here. Okay, now see, this and operator means what? Both should be true. This and that. Okay, both should be true. So if both is true, the result is true. Okay, now tell me one thing. If this is false, what do you think would be the output? If your condition 1 is false, can I say the whole output would be false? If condition 1 is false and anything else in the world is always false, right? Which means if I have written a code here, and if this code evaluates to false, then this part will be ignored. This part will never even be evaluated. Okay, and that's the reason we call this as a short circuit operator. Which means if this condition goes false, then this would not be even checked. It will say okay, false. Okay, so if both is true, then only the final output is true, right? So I'll say if first condition is false, second condition would not be evaluated. Okay, second condition would not be evaluated. Let's see the example. Okay, let's say well x is equal to 10. We've defined a variable x is equal to 10. Okay, let me say where y is equal to 20. Okay, we've defined another variable y is equal to 20. Let's define another variable where num is equal to 5. Okay, so you have got three variables here. I'll call it variables whether I use val or var. Okay, I'll not call it value. Okay, but you should understand that val means constant and variable means they are changeable, right? Okay, so we've defined three variables here: x, y, and num. X got 10, y got 20, num got 5. Okay, now let's see this condition. So now the condition is if num is less than x. So let's move one by one, guys. Okay, so check this condition. Num is less than x. What is num? Num is 5, x is 10. Is this true? What is the value of this part? Is this true or false? It is true. So this condition is true. And I have got or here, right? So in case of or, what happens is if the first part is true, then can I say the second part need not be evaluated? Yes? Are you guys understanding me? Because see, it's or, right? It's something like this. If you score 90% in your exam, or if you get 100 in computers, I'll get you a laptop. Okay, if I give you this opportunity and if I say either you score 90% throughout the subject or you just score 100 in a computer and I don't care about the rest, and if somebody scores 90% overall, then I don't have to go back and check his computer mark, right? So likewise, okay, so if this condition is true, which is true, that means I got the output is true now, okay, which means this portion is not even evaluated. Okay, so since this is true, can I say this whole if condition got evaluated to true? Can I say this whole condition became true? If this becomes true, what do you think it would print? It would print true, and it has printed true. Okay, now it has printed true. Now when you say print y, what do you expect out of this? What should be the value of y? The value of y should be 20, right? The value of y should be 20 because this part was not even evaluated. Okay, so let's go back and check the value of y. Print y. You don't even have to print y, you just say y because you are in RAPL. So just say y and it says y is 20, right? Which means it's super clear that because of this operator and because this was evaluated to true, this was not even evaluated, and since it was not evaluated, y was not even incremented. And see, if you look into this code, I have incremented my y, and that could be the reason I've defined this as var. Makes sense? You might have a question like, why did I declare this x as well and why y as well? Because I wanted this y to be incremented if at all this condition goes false. Okay, now let's do something like this. If I go back and change this logic now, see, the first condition was true, right? What would happen if I just say this? Now I said if num is greater than x. What is num? Num is 5 and x is 10. 5 is greater than 10. What is the output of this? Only this portion. What is the output of this code? This is false, okay? And if this is false, then do you agree with me that it should now go to the second portion? This is the OR operator, and it should now go to the second position to check what would be the output. This is false, right? If this is false, then I cannot tell that the final result is now false because now it has to evaluate the second part as well. It has to go and evaluate the second part. I got here false, which means let's say I could not get 90 marks altogether, right? And now my parent has told me that either you should get 90 marks as an average or you should get 100 in computer, right? So I should go and check the second condition now, right? So I'll go to the second condition because this is an OR condition. This is not AND, right? This is OR condition. So it will go to the second condition. And now what will happen is y would be incremented for sure. Y was 20 earlier. And then what will happen is y was 20. 20 plus 1. Y becomes 21. And I'm checking 21 is equal to 21. True or false? True. So can I say this whole condition is again evaluated to true? And what would be printed? True. But after this, if I try to print my y, what do you think would be the value of y? Y should be 21. And if it is 21, that means you understood this properly, right? So let's run this. I got true. But let's try to print y, and y is 21 because the second part was evaluated in this case. Okay, so probably let me add this also here. Okay, Let's move to the end part now. Now see here. Let's try this code now. Okay. Now, if num is less than x, so let's see what would be the result here. Okay. So your x is 10 and num is 5. So this is 5. 5 is less than 10. True or false? This is true. Okay. But what we have is AND operator. And if it is AND, that means it should go and check both the condition to decide the final result probably, right? See, if it is AND, in case of AND, what happens, if the first condition itself fails, then it should stop. It's not it. Let's take the example again. If I say, if you score more than 90% in the exam and you score more than 95 in computer, then you get a laptop. If that's the case, then if somebody scores only 80% throughout, then you are gone, right? That means in case of your AND operator, if the first condition is false, the whole result would be false, right? But in our case, the first part is true. And if this part is true, then what will happen? It will go and check the second part. And if it goes and checks the second part, then its value would be incremented again, right? So its value would be incremented again. Y is equal to y plus 1. Y is equal to 21. So y is equal to y plus 1. What was the previous value of y, guys? 21. Remember that we had executed it once again, right? See, the value of y was 20. But do you remember we executed this this code two times with little tweak and made our y finally 21, right? So right now it is 21. Y is equal to y plus 1. Y becomes now 22, right? Y becomes now 22 and y is equal to 21. True or false? This portion is now false and you should get false printed in this time. False, okay? But if you look into my node, it might show you true because we had not executed that earlier, right? So now it would be false and this should be 22. Second part was evaluated as first condition was not sufficient. Why it is 22? Because as I said, it already became 21 here, right? So our program is still continuing on the same REPL, okay? And hence the final output is false. And when you try to print y should give you 22. Now let's try one more time, okay? Now what I would like to do is, I would like to do the same thing with AND, but let me change this logic. Num is greater than x. So what is num? Num is 5. 5 is greater than 10. True or false? False. So this portion itself is false. If this is false, false and anything else is always false. So in that case, do you think that this portion would be evaluated? Yes or no? This portion would not be evaluated. If this portion is not evaluated, then the output, this is false. If false, means the false part and you get the output as false. Okay. Now if you try to print your y, what do you think is the output of y? 22, because that's the last output that we had. Okay. So I'll copy this and let me say this. Okay. So this is false and then anything. Are we good with this? Did we understand why it is called as a short circuit operator? This is called a short circuit operator because depending on the situation, the second part would be evaluated or skipped. And what is that condition? The condition is very simple. If you're using or, right, that means this or that. In that case, what happens? If the first part is true, you're done, right? If you're dealing with AND, if the first part is false, you are done. Okay, look into this. In or, if first condition is true, then the second condition would not be evaluated, right? Or condition. If you score 90% in exam, or if you score 100 mark only in computer, you get a laptop. Which means if the first condition is true, second condition would not be evaluated. Okay. Next, in AND operator, if first condition is false, then second condition would not be evaluated, which means if you score 90% overall and if you score 100 in computers, then only you will get a laptop. But the guy scored only 80. If that's the case, the first condition itself said false, the second part would not be even checked. We don't even care about checking his computer marks because he scored less than 90% in the first part itself. Now, what the difference? See, we saw these operators, right? But then we also saw that there was operator something like this. Now, these are called as logical operator. These are called as logical and logical or. This will have both the conditions evaluated. So don't get confused, okay? Double and double or. They are short circuit operator, but these are not. They are logical operators, right? And what is the logical operator says? The logical operator says, so the logical operator are this, right? The short circuit operators are this. The logical operator, this is AND, right? And this is OR. Let's create the truth table, okay? As a true, false, true, false, true, 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 false, false, true, false, false, okay? Now, if you talk about this AND operator, AND says if both are true, I'll be true. If I get one condition and if I get another condition true, then I'm true, okay? If I get false anywhere, then I'll be false. True, true. In this case, it will be true. Okay. False, false, false. If you're using this AND operator. If you're using OR operator, it says if I get true anywhere, I'll be true. Right? So if I get this would be true, this would be true, this would be true, this would be false. In case of your OR operator, right? Whereas these are basically the short circuit operator. Now the difference is in case of short circuit operators, second part will be evaluated or not, that depends on the condition. But if you're using AND operators, both the condition would be evaluated irrespective of what happened in the first case. So there's a question, in which case would you need a single ampersand and not double ampersand? See, when you are writing your code, basically you would be writing AND operator always, okay? Now the reason why I taught you the single operator is they exist. They are there only when you want to do some, bit level operations, because they are logical operators, okay? And you should never get confused over and double and, okay? Whenever you're writing your code, if condition and all, you'll always be using double and operator and double or. You will never use this logical and or, because that's not what you're looking for. Let's move to the next part, type inferencing. What do you mean by that? The ability to determine the data type based on the value is called as a type inferencing. Always prefer using type inferencing instead of explicitly typing, since it makes the code short. However, you can use explicit type when you want to make sure your intended data type is assigned. Okay, check this out. See, what if I say, well, x is equal to 10? What will I get? I'll get x is of integer type. Why? Because 10 by default is integer. But let's assume somebody has written a method and that method accepts only byte, right? That method accepts only byte. They don't accept integer. If that's the case, then what is the data type you need? You need byte, not integer, right? So in that case, you may be interested to say, okay, well, x of byte type is equal to 10. Are you getting my point? When should you use this explicit data type here? Whenever you need, for example, as I said, somebody has written a method and that method expects you to pass only byte. If that's the case, then why not say, well, x colon byte is equal to 10 instead of receiving this 10 as an integer and then converting that back to byte. Okay. Similarly, let's say, well, y is equal to, or else you can also do something like this. You may say 20 dot, then call some method 2 byte. Okay. So when you say 2 byte, it converts that to a byte. That also you can do. Can we change the data type of a var? No, you cannot. Var means you can only change the value of it, not the data type. Okay. Now, every arithmetic operation that you perform will always return you integer. In the below code snippet, we're trying to add 2 bytes, which will return you integer. So see this. Whenever you are using plus operator, either in Scala or Java, it holds true for both. Okay. Whenever you are performing plus operation on two integer kind of data types, then the result will always be integer. For example, if you see this code, x is 10, but what is the data type of x? X data type is byte. Okay. Y, what is the data type of y? Y is also byte. Okay. And what I'm doing is I'm saying, well, z is equal to x plus y. If I do this, many people would get confused. Probably I'm adding byte and byte. That means the computer should say, hey, Z should be a byte type, but that's not true, right? So every plus operation or any arithmetic operation that you ever perform would always result in integer. That's something you need to understand. People get confused here as well. Okay, so every arithmetic operation that you perform will always return you integer. In the below code, we are trying to add 2 bytes here. X is byte, Y is byte. What are you doing? You are trying to add 2 bytes. But what would be the resultant data type? It would be integer. Okay, we are adding 2 bytes which returns you integer, and then we are using 2 byte present in integer class to convert the result to byte. So you can also do something like this. If you want to say, hey, I want to add x plus y, but I want to see the result as a byte type, not integer type. Okay, if that's the case, then probably let's try something like this. First we'll try something like this. Dot 2 byte. Can I do something like this? Yes, you can. Okay, but what happened here, I said x plus y. This will give me integer 30. That 30 is converted to byte. That's what we have done. Okay, or else you can do something like this as well. Let me copy this. Okay, but if you look into this looks like, we have called the method, right? So see, whether you do this, see, when you say, well, z is equal to x plus y, what is your x? X is byte, y is byte, and you are trying to add the number, plus will always result in integer. Okay, and as you know, in Scala, plus is not an operator anymore, it's a method. So let me call this method. This is a method call. I'm calling plus method on x object. Okay, so this is going to return me an integer, and on that I'm saying 2 byte. That's perfectly fine. You can also do something like this. Okay, let me copy this, and let me also do it like this. Okay, next, in the below example, y itself is a byte which was converted into byte, no meaning, later the addition is happening, which results in integer again. So let's try to write something like this. Well, z is equal to x plus y dot 2 byte. If you do this, then what you are doing, this y is already a byte, and you call this 2 byte on y, which will return you back a byte, a useless operation that you are doing right now. Okay, and then the addition will happen. So when the addition happens, the addition will always return you integer. If you want to get the byte type, you should always do that after the operation is completed, right? You should basically write x plus y within bracket and then convert that to a byte. That makes sense, because x plus y will give you integer. Integer dot 2 byte will give you back a byte. Okay, but if you miss small bracket here, if you don't write this within the bracket, then this 2 byte will be called on y object itself. See here, in the below example, y itself is a byte which was converted into byte again, like useless stuff, right? And later the addition is happening, which again results in integer. Okay, now arithmetic operation will always result in integer, and trying to assign the result to a byte directly will throw you an error. Like if you do something like this, if I say x and y are bytes, plus will give me integer, and if I try to do something like this, okay, then it will throw you an exception. It says x plus y I found integer, whereas you are trying to assign it to a byte, which is not allowed. Now, while adding two numbers, even if the two numbers are of byte types and hold small value, still the result will be integer. So you cannot assign it to byte as shown above. Whatever you have done is not correct. Okay. Now, what is the solution to this? Remove the byte declaration from the statement and let Scala define it as integer, or explicitly declare z as integer. Typecast using below approach. There are two approaches. Let's see that. Number one, what you can do is this, which we have already covered in the above example, right? You can say, okay, let me do this x plus y, which will give me integer, and this integer let me convert to a byte, and when I do that, I'll get this z as a byte type. That's perfect. This is one approach that you can follow. Let the addition happen, let it return integer, and then let's convert that to a byte. Done. There is a method which we saw yesterday as instance of, okay, that can help you to convert the value from one data type to another data type. For example, x plus y will give me integer, and I'm saying I want to convert that as instance of byte. You have to write it here. What do you want to convert that to? Okay, and when you do that, this will give you a z of byte type. Okay, now what is the range of your byte? If you remember, minus 128 to 127, is not it? So byte can hold a maximum number between minus 128 to 127. So let's check this out as well. Can I say, well, x, which is your byte type, is equal to 127? It's allowed because that's the maximum value you can store. Can I store 128? No. Why? Because 128 is larger than the range whatever it can hold. It's something like this. Can I store 2 liters of milk in a container that can hold only 1.8 liter? No, right? That's something like this. It goes beyond the range, and if it goes beyond the range, you cannot hold it. You need larger data type then. Okay. However, can I do something like this? Let me say 128.2 byte. And if I do that, then it gave me minus 128. So we were talking about this. Well, x is equal to 128.2 byte. When I do that, it gave me minus 128. Why? Let's understand that. Okay. So see, the whole integer type of data type, like your byte, integer, long, okay, they all follow the concept of a clock. Okay. Now see here, let's look at the clock. What comes next to 12? 1, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then back to 1. Is not it? Similarly, when someone says it's 14, it's actually 2. If somebody says the time right now is 14, that means actually it's 2. Is not it? Now, byte range is minus 128 to 127. So if you try to convert 128 to byte, it will go to the next value, that is 128. So 127 is the limit. And if you say I want to add one more, then it goes to the reverse direction and it takes you to 128. Okay, so let's look into that as well. Now look into this clock, right? So this is the clock pattern for your byte. Okay, now when I say, well, v is equal to 127, that means this value. When I say, well, v is equal to 128.2 byte, I know that 128 is out of range. And if I say, if I want to convert this 128 to byte, then what happens? It goes from here 127, 128, so it's minus 128. If I say 130.2 byte, then it would be 127, 128, 129, 130. This value would be minus 126. Okay, that's how you should understand. This is what you're going to get if you're trying to, typecast the value which is larger than what it could actually store. 127 was 127. This is also 127. But when you add these two, x plus y, 127 plus 127 dot 2 byte, it gave me minus 2. Because of that formula, it goes to the reverse direction. Okay, so well, x is equal to 128. Well, y is equal to x plus 2 byte. So 128.2 byte will take you to minus 128. Why? Because the cycle can go till 127, and after 127 it starts traversing in the reverse direction. Okay, now so there's a formula which you can use to know what would be the new value. Okay, so let's see that formula. Fine. Now what is the range of byte, guys? The range of byte is this, right? Minus 128 to 127. If you get a value within this range, then the new value itself is n. Okay, if the value n is greater than 128, then you can use this formula to find out what would be the new value. N modulo 256 minus 256. Similarly, n is less than or equal to minus 129, then the formula would be something like this. Let's realize that. Okay, so what if I have 500? If I say I have got 500 and I'm trying to convert that to byte, I got minus 12. How is it so? How can I actually remember that? It's very simple. Look into this formula. 500. So can you tell me 500 falls on which condition? 1, 2, 3. If you look into this table, the 500 falls under 2. Greater than or equal to 128. Right? Alright. So what is the formula? That number modulo 256 minus 256 is equal to, now when you do this modulo, it gives you the reminder. Okay, so if I say 500 minus 256, 244, right? So it's 244. The remainder is 244. Why? 256 into 1 is 256 and the leftover is 244. Minus 256 is equal to minus 12. That's how it is. Okay. Similarly, if I ask you what would be the value of minus 1500.2 byte, then you got 36. Now tell me, this minus 1500 falls under which range? It falls under 3, category third. If n is less than or equal to minus 129, okay? Now the formula becomes this. So minus 1500 modulo 256 plus 256. Now here when you do a modulo of this, you get 220. Why? Do it like this. 1500 divided by 256. That means 5. Okay, 5. So 256 into 5, 5, and you can say 1500 minus, right? You get 220. So when you get 220, this becomes minus 220 plus 256 is 36. Okay, there's a question. Can you solve for 514? If you want to do it for 514, let's try that out. 514.2 byte. It gives you 2. Again, go and follow the same formula, right? When you say 514, it will again come here. 514 modulo 256 minus 256. How much it gives you? 514 modulo 256 minus 256. But again, yeah. So again, it is under your, it again goes to the cycle, right? Because it's still out of your range. So again, we will have to go back to this condition, category 3, right? It will fall under category 3. So again, it would be like minus 254 modulo 256 plus 256, right? So it again comes back to 2. No, it falls in the category 3, right? Because the n what we got is minus 254, right? Which is again beyond the range. No, your n was 514. Yes, your n was 514, but what happened was it got evaluated with this formula and then it got minus 254, right? And when you get minus 254, it is a cycle altogether, right? That means what I'm trying to tell you here is, if you say it's 14 p.m. right now, that means it is 2, right? And if you say if I'm traveling now and it will take 50 hours for me, then also it means somewhere between 1 to 12 only, right?